Hello everyone, my name is Engineer Alide. We are on to question 5, and in this question 5 we'll be talking about more difficult question, more complex, and we have to listen to get it. He said in an experiment, a student placed a charge of -6 microcoulomb between two charges of magnitude 5.5 hello, excuse me, 5.5 microcoulombs and 4.5 microcoulombs, full stop. Now, we have been told that -6 is placed between this and this. So let's just place this 5.5 here. You can put it on the left, you can put it on the right, plus. And let's place another one here. There is a 4.5 microcoulombs. Now, from the question, that's what we are told. Let me enlarge it so that you can see it very well. This plus 5.5 microcoulombs. Now, the question says that a student now placed a charge of -6 microcoulombs between two charges, which is this and this, between them. That means, let's draw our line of action. And in between them, they didn't tell us distance yet. We have our minus what? 6 microcoulombs. Now, between the two charges. Now, if the distance between 5.5 microcoulomb and -6.0 microcoulomb is 28. That means between what this and this is what 28 centimeter. And the distance between -6 microcoulomb and 4.5 microcoulomb is 41 centimeter. Somebody else can put it like this, it doesn't matter. Then between there and here is 41 centimeter. So this is what we have now. Now, clear, we have interpreted the question. If you miss the interpretation, you have failed the question. It now says, calculate the net electric force on the -6 microcoulomb charge. Calculate the net electrostatic force on the -6 microcoulomb charge placed between the two of them. Now let's go. We have option, give it to us. We don't look at the option, let's see the solution. Now, first of all, we know that if you have a positive and a positive charge, they will repel. Similarly, a negative and a negative charge, they will also repel. What this column source says, it says like charge repel, like charge repel. What is saying? That means a positive charge and a positive charge will repel. Then a negative charge, a positive charge and positive charge will repel. Then a negative charge and a negative charge will also repel. That's what he's saying. But what about a negative and a positive? A negative and a positive part will what? Attract. They will attract each other because they are what? Unlike charges. That's why he told us that what? Like charges repel, while unlike charges attract. Now, let's use this principle to solve. And again, don't forget, the closer the distance between two charges, the higher the force. That means if you have two forces now, two magnets, one is closer to a magnet. You have a magnetic substance, for instance, two of them placed at a different distance or different distances from what? From a magnet. Now, if this substance, one is placed 2 meters and another one is placed 3 meters, we notice that the one placed 2 meters will be attracted more to the magnet than the one placed at 3 meters. Reason being that the closer the substance to the magnet, the higher the force. The same thing applies to charges. The closer the distance between the two charges, the higher the force. While the farther the distance between two charges, the lesser the force. So according to what? Coulomb's law, F is inversely proportional to R squared. Don't forget. So that's why sometimes some book we call it inverse square law. Now let's apply it now. Now there's a positive charge here, there's a positive negative charge here. What will happen? This one will influence this one to make it what? Attract. So there will be an attraction here. What about this one? This one will also attract, but we are not interested in this one. We are not interested in this attraction. You understand now? This one we are not interested in this one. We are interested in this. So that's why I put X on that particular word first. Now this one, now this is positive also, this is negative. This positive will influence this charge to this negative charge to what? To cause an attraction towards its direction. So this one will also attract, because like charges repel while like charge attract. So this one will attract, but we are not interested in that one. So we cross it out. So our force that we are interested in, let's call this one Q1, Q0, and Q2. So if that is Q1, between Q1 and Q0, let's call it F10. Between Q2 and Q0, let's call it F20. So if you draw the diagram out, what we are going to have on -6 microcoulombs is that we are going to have one force moving like this, F20. Then we have another force moving like this, F10. Now, which one is greater between F10 and F20? From my explanation now, F10 is having a smaller distance. F20 is having a bigger distance. It's obvious that 28 centimeter is higher than what? 41 centimeter. Therefore, F10 creates a more force, a more attractive force on what? -6 microcoulomb than F20. So F20, because the distance apart from the force influencing it is 41, and the force influencing what -6 from the left is what? Distance of 28. Therefore, we have what? A higher force. So therefore, we can now conclude that F10 is greater than F20. Now, another thing again is that if we check what is the direction of the forces, if we want to calculate the direction of the forces, we have to look at the direction. It said when two vectors are moving in opposite direction, you add, but when they are moving in the same direction, you subtract. So that means that since they are moving in opposite direction, what is our net force? The net force on the Q -6 microcoulombs is now what? The bigger force F10 minus what? The smaller force F20. So since we now have the net force to be that, it's now very easy to solve. So let's solve our F10, solve F20, and subtract, and we'll get our net force on the what? -6 microcoulombs. So that is just that, very simple. And why do we subtract? Because they are moving opposite direction. The direction in quote created by 4.5 and 5.5 is what? On -6 microcoulomb are what? In opposite direction. So what is F10 now? F10 is what? Q1 Q0 all over what? R10 square. Now what is R10 square? R10 square, or R10, is the distance between Q1 and Q0, which is 28 centimeter. To convert centimeter to meter, you divide by 100, is 0.28 meter. If you divide by 100, then if you what? We have our Q1. Q1 is given already, which is what? 9. That means K is 9 times 10 power 9. Don't forget, 9 times 10 power 9 is our K. So put it there. What's our Q1? Q1 is 5.5 times 10 power what? -6 microcoulombs. What's our Q2? Our Q0 is absolute of -6 times 10 power what? Microcoulombs over what? What is the distance apart? The distance apart is 0.28 all square. Now, please don't forget that when you are solving for F10 and F20, they must be in magnitude. Don't make use of their what? Their negative sign. You must. That's why we take absolute of this so that our answer here will not be what? Positive. Since we have already what? That means anything you are going to get for F20 and F10, you must ensure you are calculating their magnitude. So magnitude between 2 and 0, charge Q2 and Q0, and magnitude of what between what charge Q1 and Q0. So that's why I take absolute. And if you press your calculator very well, you are going to have what 3 point what 7, press it 68 Newton. Leave that one first. Now if you get that one, keep it first. Now what do we do for the second one? This F10. F20 is what? We take our absolute of that one too. So which is what? K Q0 or Q2 Q0 all over R20 square. So what do we have now? We are going to have what? 9 times 10 by 9. Absolute of what is Q0? Q2. Q2 is 4.5. That's why minus 6. While Q0 is still remain what? Minus 6 times 10 by minus 6 microcoulombs. I mean, sorry, minus 6 times 10 by minus 6. Change the microcoulomb. Divide by what? What is our distance apart? You convert it. The distance between them, R20 is 41 centimeter. Convert 41 centimeter to meter, you have 0.41 meter. So this 0.41 meter all square. Now if you press your calculator there, you are going to have 1.445. I think that's what you are going to have. Press your calculator and confirm 4455 Newton. That's what we are going to have as your answer there for F20. So you can confirm and pause the video and confirm it. Now look at the board. Now the last step is what? The net what? Force on Q what? Not. What is the net force on what? On minus 6 microcoulombs. So what we are going to do now is to use our what? The net force on Q0, which is minus 6 microcoulombs, is now equal to what? F10, which what is F10? Is 3.768 minus what is F20? Is 1.4455. If you press your calculator very well, if you do your calculator, you would have what? 2.34 Newton. 2.34 Newton. Now, that is not our final answer. Because what they tell you to find is net electric force, electrostatic force on Q charge minus 6 microcoulomb. Now, listen, electrostatic force is a vector. Because in the question now you are seeing minus, some of us will go and choose none of the above. That's where we miss it. Now, this is the trap on the question. We have, at any time you have an attraction dominating a system, the answer will always carry minus. Anytime you have repulsion dominating a system, you have plus added to the force. That is to say that you check the system, which one is having more influence on the net force, on the charge you are calculating our net force on, is attractive. Although the whole system here is attraction. In a complex case where we have one is giving repulsion, the other one is giving attraction, then you will know what they are saying. But because since it's an attractive force that is dominating, how? Why will it be minus? Because a negative times positive, attraction always occur between negative and positive. A negative times positive is negative, but positive times positive will be positive. Negative times negative will be positive. So anytime you solve and you notice that the system is what dominated by what and the attractive force, our answer will carry minus to be, except they ask of what is calculate the magnitude of the electrostatic force on the charge minus 6 microcoulomb or on the minus 6 microcoulomb, then our answer will just be like this. Because magnitude has to do with only the value, no sign or no negative sign, no positive sign. So that has to take, you have to take absolute of whatever comes. So our answer will now carry minus sign. Don't forget, if repulsion dominate the system, it will be plus sign. So that is what will be our answer. So the answer is option C. So till next time we shall see again, same time, please ensure you what click the notification button and subscribe. My name is Engineer Holiday. God bless you and enjoy your day.